We have a special talk by Professor Robert Twiggs. He was the co-developer of the CubeSat concept and was responsible for developing the original concepts for the CricketSat, CanSat, and the PocketQub for educational applications. So, Professor Twiggs, you have the floor.
Thank you. Well, this is an exciting forum to be part of, and to see everybody so excited about doing things in space. And as this whole thing started, as Professor Sanichi said, was just a coincidence at a conference in Hawaii to challenge the students to do something with a can. And I had been drinking a can of Coke like this at the podium when I got up, and then the thought occurred, you know, maybe we could do something with this. So I challenged the students, and the response come back from the Japanese students that just kind of overwhelmed me, because generally the Japanese students are fairly quiet in the audience and don't say too much, but they jumped up and said, "Can do." And I thought, boy, we've got something going. And look at what happened. Look at what happened. And our original thought, as Sanichi said, to go into space, but then, you know, that's pretty difficult to get into space. So the prospects come along to do something with the high-powered rockets in Nevada. And the Japanese showed up in force, and I think they have done every year since, to come to Nevada in September. And we started out with CanSats and shooting them up to 15,000 feet and bringing them back down on parachutes, and then trying to find them out in the Black Rock Desert. Lots of fun. I'm sure that was as much of an experience for them as it was for us. And then they come along and said, well, this isn't challenging enough. We want something, let's call it a comeback challenge. And that comeback challenge was to put something in this container that we'd had the CanSats in, and to launch that and have it come back to a flag near the launch site. And that's quite a chore, because you're very limited in space in this carrier for the rover that they built. But they did build rovers, and it wasn't successful initially. I think it took like 4 years before they finally got one to come back. And the development over those 4 years was amazing. It was from the original rovers that got tangled in the parachutes when they landed. They run out of power. They just kind of plodded along. And as we got near the end of near 4 years, the rovers would hit. They wouldn't get tangled in the parachute. And I've got some video that if you can go to YouTube and look at for ARLIS and rovers, the students had rovers that they had to run to keep up with them as they were heading back to the launch site. And to see the rover come in and actually hit the flag at the launch site was an amazing thing. And who thought that hitting that flag would someday lead to hitting an asteroid? It just is amazing. So one of the things, I don't want to take a lot of time here, but one of the things that we got into the CubeSats and got into the CanSats for was education of students. And this was an environment where you can fail. And as was said, you don't learn much unless you fail. And so this gives the students an opportunity to fail without criticism, as it was a part of the original experience. If you remember, NASA at the very beginning had a lot of failures, but as years went on, they public become more critical of their failures, and to the point where they were kind of afraid to do anything for fear of failures. And you know that when they decided to build a satellite, there was so much work put into trying to make this satellite successful that it took years, and the years made them use old technology. What's the CanSat using? The CanSat is using the CubeSat's using technology that was developed yesterday, and we don't care what the technology is. We don't care that it has a TR level. We don't care that it's radiation resistant. If it'll do what we want, we put it in the CubeSat and we go fly it and we learn. Sometimes we don't learn very much. Sometimes we learn an awful lot. Finally, in 2017, we got some PocketQubes launched. And what was in that PocketQube, people would laugh at. You know, we put a little, essentially, a basic processor in it. We put a little radio in it that everybody says, that isn't gonna work. You've got a little milliwatt radio. But we said, hey, look, let's use Morse code. Good signal to noise ratio with Morse code. And it was a learning experience. And you know what? One of those PocketQubes lasted almost 2 years. It is amazing what the technology would do. And I don't think that the projects that we're doing now, if they hadn't coincided with the cell phone industry, with the miniaturization of electronics, probably would have not happened. Maybe if we'd have proposed it 10 years earlier, it would have not happened. The other thing is I've often got asked, well, why didn't you patent the CubeSat idea? And, you know, first of all, it come about so fast, we never thought of patenting it. But I think that the thing that pushes technology is the ability to not restrict it, not patent it, not do something that makes a lot of money. You know, my philosophy is, and I get criticized for it a lot, I like to give everything away. Hey, whatever we're going to do, tell people about it, give it away. The more you give away, the more you get back. And that's been so much fun. One of the things that I would like to encourage everyone doing while you're thinking about going to deep space and all of these great things, think about something you can do for the kids in the education system. Can you build some little device that they can use to do measurements and learn something from? Can they have this little device that they set outside the window, and maybe it measures the temperature and it's sending the data back by Morse code? Or could they have something that has a little transmitter on that they put on a balloon, and it goes up in space and it just measures the temperature that goes up in space? We have a little thing we call a CricketSat that does that sort of thing. Think about building those things, but you gotta build them really inexpensive, because the education system doesn't have a lot of money. Every student starting, I don't care, even if it's in kindergarten, ought to have some little device they could stick in their pocket that gives them some science return. Because giving them the science return will have them getting excited about science, getting excited about mathematics, just getting excited about learning in school. School, when I went to school, it was so boring. You know, I was a guy from a farm community in Idaho, and I was more, they spent more time with me learning about cows than they did anything else. And fortunately, after I got out of high school, I went in the Air Force and got in electronics programming. Oh boy, was that fun. So anyway, I'd like to open it up to the audience. What can you do here on Earth right now? You don't have to spend all your time on it, but what can you do here on Earth to make things better here on Earth and to help educate the students? That's my question. So I'll open it up for questions and answers.
Ray, should they type the questions in the chat?
I think well, everybody can raise a hand and ask a question, I think.
We're open for questions. Okay, Meshack, go ahead.
Yeah, thank you so much, Professor, for that detailed explanation. I would like to repeat a question that I had asked earlier, the earlier presenter, Professor Yosuchi. I was asking about the capability of the CubeSat to perform a space solar experiment because we are planning with a team to do a space solar power demonstration project. And I don't know how you view the CubeSat with the capability to do that.
Well, you know, it's amazing. If you ask me the question, it's amazing what people have done with CubeSats. I think that one of the interesting stories that I have to tell is one of the first 1U CubeSats that was launched. They talked about getting pictures back from. The students asked me if they thought they could put a camera in the CubeSat and get it to work. Well, you know, with my wisdom and great experience, and I said, I don't think it'll work. You know, these CubeSats are too small. You know, after they launched that CubeSat, I got a picture a week from them, I think for a year. And I see that they're still taking pictures with that. So one of the things that you need to do is tell a student that they can't do something, and then they'll spend an awful lot of effort doing it. So, you know, if you've got an idea to do something, go tell a student it's probably impossible to do it, and they'll get it done.
Okay, other people raise their hand. Go ahead.
Hello, Professor Twiggs. Can we create a CAN satellite out of our own pocket, like develop it homemade?
Absolutely. Yes, that's no problem at all. You know, one of the things that I find that I learn so much from is going to YouTube. And I like the Arduino and the Raspberry Pi. The components are so cheap there that you can do all sorts of things for very, very little money. There's a organization called Seed Studio, SEED Studio, that just come out with a little processor called Chio, and it's got an ARM processor in it. You can program it with Arduino. These things have the most capability that you could ever believe. They've got more power in a little processor like that than probably the computers in the space shuttle. So don't let cost be a limit. And go to YouTube and look and see the things. There are all kinds of companies making parts. There's Adafruit, there's Spark Fund, there's all of these things. There's so much good stuff out there that it would make it so easy to do a CanSat now, and even a CubeSat. Like I said, we flew a PocketQub that went up, and it was at like 450 kilometers, and we had a little milliwatt LoRa transmitter in it, and we got data back from it. So, you know, the challenge is you will have some limitations, but go get some data any place that you can get it. Like I say, you know, if you want to fly something in space, if it gets above the height of a house, you're in space. So go do it.
Klaus, go ahead with your question, Klaus.
Yeah, Bob, thank you very much. And I think CubeSats must be small, so performance is limited, but we can combine several CubeSats, yeah? And combining into formations offers a lot of new potential of very innovative science, distributed systems. And I think it's similar, like we encountered both, that when we grow up, we had mainframe computers. Today, we have the same computation performance in our pocket with the smartphones. And I see also in forming larger formations, constellations of small satellites, the potential for a lot of international cooperation. So a single CubeSat can be limited performance, but the performance of a team, of a group, might be quite exciting.
Okay, Klaus, thank you very much.
Yeah, I think that is an excellent idea. I think having an international cooperative project with something like that would just be wonderful. You think about, you know, if like you're saying, you know, if you want to make a significant measurement, maybe the individual satellite can't do it, but the combined constellation can. And I think the more we can have international cooperation on programs like that, the more exciting it is.